Question number 2. A radioactive source emits alpha, beta, and gamma radiation. 2.1 is an AO1 question. An alpha particle is the same as helium nucleus. How many times bigger is the radius of a helium atom than the radius of alpha particles? Tick one box. So we have three different options here. If we take the alpha particle as a helium nucleus, it means the size of the alpha particle and the size of the helium nucleus, they are same. The difference between alpha particle and the helium is that the helium has two electrons in the shells. Therefore, the size of the helium atom is increased due to the shell around it. It is an AO1 question, therefore student must know about the size of the helium atom, which is about 10,000 times bigger than the alpha particles. So the correct option is 10,000 times. 2.2 is an AO1 question, and this question is from the topic of mass number, atomic number, and isotopes. Alpha particles can ionize the atoms in the air. What happens to an atom when it is ionized by an alpha particle? The student must know the properties of the alpha particles. And ionization means gaining or losing of electron. The alpha particles are positive charged particles. Therefore, they will try to take the electrons from the air molecules. As a result of that, the air molecules will lose the electron. On losing the electron, an atom or the particle will become a positively charged particle. So the correct options are the atom becomes a positive ion after losing the electron. The atom loses an electron as the result of ionization. 2.3 is an AO3 question. The student needs to give the suggestion. A spark detector is a device that can be used to detect alpha radiation. A spark detector works by alpha particles ionizing the atom in the air near a wire mesh. A large potential difference creates a spark when the air near the wire mesh is ionized. Suggest why a spark detector cannot detect the beta radiation. This question is from the topic of radioactive decay and nuclear radiations. The student must know the properties of beta radiations. As compared to alpha radiations, the beta radiations are weak ionizer. When the detector is brought closer to the mesh and the beta particles or beta radiations are emitted, so they are unable to ionize the air particles. As a result, the detector is unable to detect the beta radiations. So the correct answer is that the beta radiations are weak ionizing radiations. Therefore, the detector is unable to detect the beta radiations. The correct answer is beta radiations are weak ionizer. Beta radiations are weak ionizing radiations. 2.4 is again an EO3 question, and this question is from the topic of radioactive decay and nuclear radiations. A teacher wants to demonstrate that radioactive source emits alpha, beta, and gamma radiation. Figure number 3 shows the equipment that the teacher has used. There is a count rate meter. There is the radiation detector. A source is present. A thin sheet of paper and 3 mm thick aluminum sheet is present there. Describe a method the teacher could use. If we look into our count rate and radiation detector, we can see here, first of all, the teacher will bring this detector closer to the source and get the reading before putting any of the obstacle between the detector and the source. Then the teacher is going to put a thin sheet of paper between the detector and the source and find the count rate on the meter and compare the value with the initial value. Then the teacher will put the thin aluminum sheet between the source and the radiation detector and find the value of the radiations on the count rate meter and compare it with the initial value. Let's see the model answer. Move the detector very close to the radioactive source and measure the count rate on the count rate meter. Bring thin paper sheet between the radioactive source and the detector. Measure the count rate. If the count rate is significantly less than without the paper, the source is alpha particle source because the alpha particles cannot penetrate through the paper easily. Bring thin aluminum sheet between the radioactive source and the detector. Measure the count rate. If the count rate is significantly less than without the aluminum sheet, then the source is beta particle source because beta particles cannot penetrate through the aluminum easily. Gamma radiation can pass through paper or aluminum sheet easily, and the count rate will show almost the same reading with or without using the paper or aluminum sheet.